In this video, we're continuing our work with Ohm's law, and we're talking about series parallel circuits. All right, so we're back to our ATEC board here and using light bulbs to try to give some visualization to how is current, how is electricity going to act when we go through a series parallel type circuit. So if we get this turned on and we start with just a simple single bulb series circuit, you can see we've got quite a bit of brightness. And if we measure the current flow through this bulb, it's about 0.248 amps, right? So maybe a quarter of an amp. If I go ahead and add a second light bulb, and I put it in series with that first light bulb, we expect that the two light bulb resistance values are going to add together because they're in series. When they add together, the total resistance doubles from just my one light bulb. And as a result, as resistance goes up, current has to go down. So we see that about half the current goes through each bulb, and it's apparent through the brightness. The brightness is about 50% of what we had initially. The next thing that we could do is look at how do these bulbs behave in parallel, right? And so if we start by thinking of what's at stake and what's available, we know we've got the same 12 volts that's going to be available to both bulbs at the same time. And so you've got to ask yourself, well, what's current going to do? And we've got to have some understanding of Kirchoff's laws and what that means for resistance, right? And so with parallel, I've got the same voltage going to both, but we know that the total resistance experienced by the power source or the battery is going to be less than the smallest. Or if I've got two essentially similar loads, two of the same resistance values, it's going to be about half. Right, and so with that, we could expect that we should get a pretty bright light bulb. So I get this set up. So there we go, we've got quite a bit of brightness, almost the same brightness that we saw when we had one bulb in series by itself. With an amp meter hooked up to this, we see that it's 0.496, 0.495 amps, right? And so it is almost exactly twice as much amperage going through this whole circuit than when we had just one individual bulb, right? And that makes sense because I've got two bulbs in parallel. Their current values get added together, right? And that's where I get that double in current output. So then what happens when we add both types of circuits together? So when we go from just having a parallel circuit to having a series parallel circuit, say like this, where I've got just a single bulb down here and I've got two bulbs up here in parallel. Well, we know that anything that's in series, the resistance values are going to add up. And so my total resistance for my parallel circuit becomes a group. And this is one of the most challenging things, I think, when we initially start talking about series parallel, is you take these new rules from Kirchoff and Ohm's law, and you try to apply them. But we've got to remember that we can't intermix the rules when we're doing series and parallel together. I've got to try to compartmentalize that this parallel circuit is really acting as a single resistance value in a series circuit, right? So imagine that these two bulbs are together like this, and it is just a single piece of the circuit. And so when I look at how does this behave versus this, I've got to consider the totals that are going through those two bulbs as a parallel unit, right, and as a group. And so when we measure total current flow through this whole circuit right here with parallel and series, we're looking at about 0.217 amps. And so that is just less than what we had for a single bulb. It's less than what we had for the two parallels. And why is that? Well, I've got the resistance of one bulb is still present, but I've added half the resistance of this other setup, right? And so I see this reduction because resistance has gone up a little bit, and then that means that my total current flow has to go down. So hopefully the visualization of how the bulbs react, their brightness change, effectively what their current value is, seeing that as a visual hopefully helps with how is current going to flow as it goes through a series parallel circuit. Let's take it a step further though, and let's look at some of the math with Ohm's law of how we might calculate unknowns, right, if we were given a circuit like this. In order to plug some of those things in, we're going to have to get our source voltage. So we're going to go ahead and get that. Looks like we've got just about 12.05 volts. So let's take that, we'll use a table on the computer and look at what are some of the unknowns. We'll figure out our resistance values, and again, talk about how do I group these for considerations with Kirchoff's laws. All right, so we're at the computer here. We're looking at an Excel spreadsheet I put together. This is a table that we use a lot in our courses to try to outline all the different values that are occurring in a circuit so that we can work on reinforcing Ohm's law, reinforcing Kirchoff's laws, and just try to present it as clean as possible. But one of the downfalls of this table setup is that when we get to do a series parallel, it does become more complicated. And so we're gonna use this and try to talk through maybe what I should do in order to overcome that. So first I put in some of our values. I've got 12.05 volts as my source, and this is for the circuit we just did with 2 bulbs in parallel, followed by a third bulb that is in series. We saw 0.217 amps going through that whole circuit. This 55.52995 ohms is just part of an equation, right? So at the top you can see product of, it's doing that division for me. And so our goal next is to figure out what else is happening in this circuit. And to make that easier, I did some voltage measurements, and there are 9.14 volts going through my third bulb. And then I've got some values for these as a group. And we can make another assumption here, because my third bulb is in series, it's got to consume all of that 0.217 amps. And so I could work through that. We could take this guy over and see that we're making some progress. So you might see another table at the bottom. One of the challenges here is when I do a series and a parallel circuit together, I can't apply the same rules throughout the whole table. And I've got to look at them as segments. And so really, if we take this center section here, let's make it a new color, and match that down here, this is my goal. I want to take what happens as 1 and 2 in parallel as a group, and I need to figure out what their total is. How do they behave as one total unit? Because once I know that, I can apply that just like I would as a series circuit and fill out the rest of my chart here. So I know as a whole unit, they've got to consume that 0.217 amps as well. And I did some other measurement to figure out that we've got 2.89 volts going through those. And I could have done some other math here. Take this 12 minus 9.14. That would get me there too, right? So say that I didn't have a measurement. I could use Ohm's law to my benefit if I know which numbers to pull. So I can do those. That leaves me with my total resistance here. I'm going to go voltage divided by my current. That gets me my resistance. And so now, knowing that these 2 bulbs are the same load, I can take this and just say, hey, it is a parallel circuit, and so I know that these are both going to be the same. I'm going to run the same voltage through both of these loads because they're wired in parallel. As a result, they've got to share the current that goes through them. And so that current becomes 10.085 because it is half of each. And you can see this is populated. I've got another formula in my resistance box here. And so each of them are consuming or have about 26 ohms of resistance. The total is less than that, right? We expect that. They are the same, so it is half. But we know as Kirchoff's rules go, this has got to be less than the smallest branch resistance value. So now that I've got these, I can go back up and I can apply these into my table if I desire to do so. And so I plug all these in. It's a whole lot of numbers here, but to be consistent, right? And so now I've solved for that whole circuit. I hope that process helps. It's good to look at series parallel and try to understand how do they function together, how do they blend. Early on, we spend a lot of time looking at series, and then we look at parallel, and hopefully get those concepts down, as a good foundation. Applying them to series parallel does become a little bit complex, and using the table like we did can be a little abstract, but I think it is a good tool to try to understand the whole thing as it works together. It takes some time, it takes looking at it multiple times to really let it sink in, but I think it's beneficial.